Alright, so we're going to start chapter 1, and I'm skipping section 1 because it's on like graphs or something like that. Just can you read a graph, which is not something that we really need to worry with. We're going to graph things, but I don't need you to be able to pick which graph goes with the scenario, like Bob was walking up the hill and turned around and went and got his lunch. Anyway, we're skipping section 1. It's not something that you need to know. So, section 1-2 is on linear equations and rational equations. So, chapter 1 in general is solving equations, like all types of equations, just about that you could think of that you've ever solved before, are going to be in this chapter. We're going to solve linear, we're going to solve rational, we're going to solve quadratic, we'll solve ones with radicals, we'll solve, I think, some basic polynomials. We'll also solve some inequalities. I think I may have exhausted the list. There may be more, I'm not sure. Alright, so on this slide, you do not need to write down anything other than the title and this part that I starred. Read through the definitions, make sure you understand that a linear equation is an equation that can be written with one variable, like ax plus b equals 0. Solving an equation involves determining the values of x that would make a true statement. Sometimes we call solutions roots. Sometimes we call them like the answer. Anyway, there's lots of names for solutions. It ultimately means where the graph would cross the x-axis. That will become important in the next chapter. Alright, so a solution set is the set of solutions that satisfy an equation. And what I need you to know is I think the back of the book, instead of just saying that we solved and got x equals 2, they're going to write it as the solution set, so they'll just put it in fancy brackets. So if you're checking answers in the back of the book, if you solve and get 2 answers, then you'll, I don't tend to write things like that. If you solve and get 2 different answers, then they may write it like this. So just understand that that's what that means. I don't need you to write answers like that, but they may show up in the back of the book like that. Alright, and then equivalent equations are equations that have the same solution set. Okay, so to solve a linear equation, you've been solving equations since like the 6th grade. So y'all are going to be fine. Here are some steps if you need to write those down. Alright, so 2 examples I'm going to walk you through and I'm going to give you a few to try. So I have something that looks like this. To get x by itself, we're just going to subtract 5. And then divide by 4. And we get that x is 6. Alright, example 2. You're going to have to distribute. We got to get rid of the parentheses. And then we're going to combine like terms where we have them. So on the right side of the equation, I can put together 29 minus 15 and have 14. Alright, so now you just have a simple little expression on both sides. So we want variables on one side, numbers on the other. It doesn't matter which thing you pick at this point. Pick something and do the opposite. I usually take the smaller variable and move it to the other side. So we're going to subtract 6x. This gives me 2. Bring down the 4. Gives me 2x. Sorry. This 14 comes down. Those make 0. Now it's just like example 1. We got to subtract the 4. Divide by the 2. And we get 5. Do I need to see every one of those steps from you? No. Do I need to see enough to be able to follow what your logic was? Yes, if you want some partial credit. And very soon I will stop showing that subtract 4 step. Okay, so there's 2 examples. So on this next slide, I want you to pause the video, work these 3 out, and then see how you did. Alright, so number 7, you're going to add 5. divide by 7, you should have gotten 11. Number 2, you're going to distribute a negative. And you're going to distribute that. Combine like terms on the left where you have 2 x's that can go together. Subtract the 5, divide by the 5, and you get 7. Alright, number 3, distribute to the 3. Distribute by 2. Combine like terms on each side. In this case, only on the left. Get your variables on the same side. And subtract 1, so we get 9. Alright, so that's solving linear equations. The other thing we have in this section is solve rational equations. Alright, so equations are easier to solve when they don't have fractions. People tend to not like fractions. It's easier if you just get rid of them. So we're going to multiply every piece of the problem by a common denominator so that we can get rid of the fractions. And it's just solving a linear equation. But what we do have to remember is that when we have a rational equation, when there are variables in the denominator, we have to look for excluded values. The values that make the variable, the values of the variable that make the denominator 0. Sorry, those words are not coming out in the right order. So excluded values are what value of the variable makes your denominator 0. You got to figure those out first, because as you solve the problem, you may come up with that excluded value as an answer, and you've got to be able to realize you've got to throw that away. It can't be the answer. All right. So, example 1. Trying to make it fit the width wide enough. Okay. So, for example 1, there are no excluded values. We technically don't have a rational function because we don't have variables in the denominator. It's just a linear function because but anyway, we are still going to get rid of the fraction. So we don't have to find excluded values because there's no variables in the denominator. Alright, so your denominators are 4, 14, and 7. I believe that all of those numbers can be turned into 28. So your common denominator is 28. So we're going to take each one of these and multiply by 28. So each piece of the problem times 28. Now think about what you're doing. We're trying to get rid of the fractions. So make sure you cross cancel. 4 goes into 28 7 times. So this is 7, and you have x minus 30. 14 goes into 28 twice. So this is 5 times 2. 7 goes into 28 4 times, so this is 4 times x plus 5. So now you no longer have fractions. Alright, so we have 7x minus 21 equals 10 minus 4x plus 20. Combine like terms, so negative 4x plus 30. Add 4x to 7x, so 11x minus 21 is equal to 30. Add 21, so 11x is equal to 51. Divide by 11, we get 51 elevenths. And we are finished. Oh, no, we're not, because I just said that negative 4 times 5 was positive 20, and it's clearly negative 20. Alright, so let's go back and fix that. Negative times a positive is a negative. So 10 minus 20, this should be negative 10. So this should be negative 10. So when I add 21, I get 11, so the answer is 1. Okay, number 2. Apparently not number 2. All right. We're going to take the denominators, look at them, they have x's, so we have to think about excluded values. So excluded values, if you take your denominators and set them equal to 0, you get 0. Whether you do the 2x or the 3x, it doesn't matter, right? If you need to do both of them and prove it to yourself, that's fine. So your excluded values are 0. X cannot be 0. Alright, so just keep in mind as you're working the problem, if you get 0 as an answer, you've got to throw it away, it can't be the answer. Alright, now to decide what we're going to do, we need a common denominator. So for 18, 2x and 3x, and then we can use 18x. So if we times 18x on each piece of the puzzle, 2x goes into 18x 9 times, so you get 9 times 5. 18 and 18 cancel, so that's 17x. 3x goes into 18x 6 times, so that's 1 times 6. So we have 45 equals 17x minus 6. So we're going to add the 6, that's 51. Divide by the 17, and you get 30. 30 is not your excluded value, so that's the answer. Alright, example 3. We need to know what the excluded values might be. Alright, so excluded values, we're going to say x cannot be. So you have x minus 2 as a denominator. So if we want to figure out when is x minus 2 0, that happens when x is 2. So we know x cannot be 2. 30 can never be 0 because there's no variable there. Alright, so common denominator. You have x minus 2 and you have 30. That's your common denominator. So we're going to multiply by 30 times x minus 2 to each piece of the puzzle. X minus 2's cancel, you have 3x. X minus 2's cancel, you have 2 times 3. The 30's cancel, so you have 2 times x minus 2. Alright, so we have 3x is equal to 6. Distribute this negative 2, and you have negative 2x plus 4. Add the 2x, that's 5x. Combine the 6 and the 4, that's 10. Divide by 5, you get 2. 2 is my excluded value, so I can't have it, so he's garbage, and that's the only answer that I had, which means there is no solution. So what does that mean as far as graphing? If you tried to graph this, it would never cross the x-axis. Alright, number 4. Okay, so these are supposed to be fractions, but for some reason the fraction values are not showing up. So we'll draw them all in. Alright, so up to this point, all of the denominators were nice and simple and not factorable. But if you look at this denominator, I believe it's a difference of squares, so we can say x plus 5, x minus 5. Alright, so that takes care of these two denominators, right? So when we do our excluded values, we need to know when is x plus 5 0 and when is x minus 5 0. So here we're going to subtract and we get negative 5. Here we're going to add, we get positive 5. So we know we can't be negative 5 or 5. Alright, your common denominator is the x plus 5, x minus 5. So multiply that everywhere. Alright, so here, x plus 5 cancel. So you have 4 and x minus 5. Here, x minus 5 cancel. So you have 2 and x plus 5. Here, they both cancel, so you just have the 32. Alright, so now we distribute. Combine our like terms. Add the 10. Divide by the 6. You get 7, which is not an excluded value, so that is your answer. There could be an occasion where you get more than one answer. I don't know that there's a whole big likelihood of that on this particular, in this book. I don't think they give you problems where that happens. It might, but we haven't solved quadratics yet, so they shouldn't be able to give you something with 2 answers yet. Alright, so I want you to try these 3. There's 3 of them, so let me shrink it back. There we go. Alright, pause the video, try those 3, and then see how you did. Alright, so you had excluded values of 0 and a common denominator of 9x. So on that first term, the x's cancel. 7 times 9 is 72. That's a lot. 64. Sorry. Here the 9's cancel. You get 2x. Here 3x goes into 9x 3 times. So negative 5 times 3, negative 15. Subtract 63 from negative 15. We get negative 78. Divide by 2, and you get negative 39, which is definitely not your excluded value. Alright, number 2. Your excluded value here is 3. Because if you make this equal to 0, you get 3 when you solve. Alright, common denominator is going to be that x minus 3. But here's the thing that people forget. This guy counts 2. You got to multiply him. Just because it doesn't look like a fraction doesn't mean it's not one. Alright, so x minus 3's cancel. Nothing cancels with this one. And x minus 3's canceled. Alright, distribute the 9. Combine your like terms. Add the 21. Divide by the 9. We get 2. That is not the excluded value. Alright, number 3. You've got to factor. I believe it's plus 5 minus 1. This is the same thing because it's the same expression. Alright, so excluded values. We know that we can't be negative 5 and we can't be positive 1. Because if you take this and equal it to 0, you get negative 5. If you take this and equal it to 0, you get 1. Okay, so multiply by your common denominator, which is x plus 5, x minus 1. Because that includes all of your denominators without repeating yourself. Alright, so everything cancels. You just have a 5. Everything cancels. You just have a 1. The plus 5's canceled, but you still have 1 times x minus 1. Alright, these 1's cancel. You get x equals 5. You can have that because negative 5 is what's not allowed. And you are done. Okay, there's one other thing in here. And again, it's not something that's new. It may be slightly new vocab, but I think in the Springboard Algebra 1 book they use this same vocabulary. So we have special conditions that happen when we're solving an equation. So if you have an identity, that's an equation that's true for all numbers. A conditional equation is an equation that's not an identity, but true for at least one real number. So this just means it has an answer. Or 2 or 3. So if you work it out and you get x equals 2, then it's conditional. Identity means your variables go away and you get something like 9 equals 9, a true statement. Alright, inconsistent is an equation not true for even one real number. Okay, so it's ones that have no solution are considered inconsistent. So that's if your variables disappear and you get something like 9 is equal to 5. Alright, so when you solve an equation, it falls into one of those categories. Alright, so that's all we want us to do here is solve it and then say which category it falls into. So if I take this equation, we're going to distribute the 4. At this point, a lot of people can tell what's going to happen because you see how the variables match. Well, these guys are not going to match. So you know that there's no solution because the next step is subtract 4x on both sides, and so you get this. That is not true. So there is no solution. And we're going to give it the fancy name of inconsistent. Alright, so the next slide just has you try a couple of those. So pause, solve, and see if you can give them the right category. Alright, we're going to get 2x plus 2 is equal to 2x plus 3. So 2 is equal to 3. That's no solution, which is inconsistent. Alright, if we do this time, we're going to have negative 2, positive 14. Over here we'll have negative 2 and 17. This is also 17. So at this point you should realize that they're the same, but if you take the option of moving the x's to the same side, they disappear, they cancel each other out. This is a true statement, so this is going to be where you have infinite solutions. Technically you just write infinitely many solutions. I'm okay if you just write IN. Pretend like that's an S because it's not supposed to be an N. Alright, so you have infinite solutions. If your variables disappear and you get a true statement, that is considered an identity. The two sides end up being identical at some point. Alright, all of the equations we've solved up to this point that had an answer, those are conditional. Alright, I think, what do we have next? Next is, we're not doing section 1-3 today, we'll do it tomorrow, so make sure you look at your assignment and get it done. If you have questions, please let me know.